Good evening, everyone. We are going to start within 2 to 3 minutes. Let others also join. Okay, so guys, let's start with the presentation session. So I hope that all of you have covered the project for week 4. So who wants to present first? Just raise your hands. Okay, great, Mansi. So let's start with you first of all. So you can just take your time and share your screen and let us know that what you have created. All the best for presentation.
So can you see my screen?
Yes, it is visible.
Okay, sir. Hello everyone, I'm Mansi Adiga. My domain is AI/ML. The title of my project is Food Order Preference Clustering. The goal of this project is to use clustering algorithms such as k-means and dimensionality reduction techniques such as PCA to identify distinct groups of users based on their food, drink, and dessert preferences. Data collection and preparation. Here I have imported all the libraries. Here I've loaded the dataset. This is where I've mounted the drive, and this is the dataset I've used called foodpreference.csv from Kaggle. This
Okay.
displays the first 5 rows of the dataset. Number of rows and columns. There are 288 rows and 8 columns. This is the list of all the columns in the dataset. Variable description, timestamp gives the timestamp of the survey, participant ID, gender, nationality, age, food, juice, and dessert are all the preferences given by the participant of the survey. These are all the data types. Dataset info gives the non-null count of each of the columns as well as their data types. Statistics of each column, I've used describe to give statistics of each numerical columns in the dataset. There's only one numerical column called age. So these are all the statistics of that column. For data
Okay.
cleaning and pre-processing, I've checked for missing values. And here you can see that only in gender there are missing values. We'll be cleaning this in the later part of the project.
Okay.
I've checked for duplicated values. There are no duplicate values, and these are the number of unique values in the data set. So In the data set, we can see that timestamp and participant ID are not really necessary for further modeling. So we can remove those two columns to simplify our data set. And we need to clean the missing values which are there in the gender column. So we'll be doing that next. Here I've dropped timestamp as well as participant ID to handle missing values. I've checked for the mode of the gender column and I've used mode imputation to fill all the missing values with the mode of the gender column. And after
Okay.
checking for missing values, you can see that there are no missing values. So cleaning is done. And then I've used one hot encoding to change all categorical columns to numerical columns so we can further analyze this. This is the encoded data set. Here, you can see that initially all of these categorical values were there. After encoding, they get separated based off the values in each of the columns.
Okay.
Um, this is the encoded data. And then I've done normalization by using standard scaler. Here, for the encoded data, I've applied standard scaler to get standard values for each of the columns. So none of the features dominate the other features. And this is essential for modeling. So next is EDA. I've done 5 charts. This shows the age distribution. Here we can see that through this histogram, you can see that the data is right skewed as all of the data points are collected in the left side of the chart and there's a tail extending towards the right. And you can see that the age group 20 to 30 has the highest frequency in the data set. So when we're
Okay.
doing clustering later on, that really impacts the clusters which are going to be made. This is the gender distribution throughout the dataset. We can see that there are a lot more female participants in the survey compared to the male participants. For chart 3, it's food preference distribution. Throughout the dataset, we have traditional food and Western food. And we can see that there's a lot more participants which have opted for traditional food compared to Western food.
Okay.
Chart 4 gives a correlation heat map of all of the features. Here I've used the scaled feature as well for the correlation. So we can see for each of the features. Otherwise, we had only age as a numerical column. We can't really check for correlation. So in
Yes.
this, we can see that only the diagonal in the middle has strong correlation. That is because each of the features are correlated to itself, whereas the rest of the map is mostly in the dark colors, showing that it's near zero or has a very low, weak negative correlation. So this is suitable for clustering. For chart 5, I've
Okay.
done a box plot for age. Here you can see that the median age is 28, and most of the data points are uh, from the age 24 to 36. And here you can see a few outliers after the age of 55-ish. So these are all the older participants who have taken the survey. Next, I've done dimensionality reduction. Here I've used PCA on the scaled data. For explained variance, this calculates the cumulative variance of each of the features. So here in this code, this line gives the index of those features which have cumulative frequency which is greater than equal to 90. So we'll check all of those columns which gives 90% frequency. So that is still here. Here we
Okay.
have 26. So 26 features will be used. PCA is going to be applied on the data set where it's taking only these 26 features as it explains 90% of the data set. So that is dimensionality reduction. Next, for clustering, I've done the elbow method, silver score, and then I've applied their means. For elbow method, in this, it calculates the WCSS for 10 iterations. That is for one cluster, two cluster, three clusters, until 10 clusters. We calculate the WCSS that is within cluster sum of squares. And here I've plotted the WCSS against the number of clusters. Here we can see that there are no elbow in the cluster. Like there is a decrease in WCSS, but there's no uh, decrease in the WCSS. It's throughout it's decreasing, so there's no elbow. We can't tell that which k value gives the optimal number of clusters. So we'll do
Okay.
silhouette score, because through silhouette score we'll get to know how close the points are within the same cluster, as well as the distance between two clusters. So here the silhouette score gives value from -1 to 1, and whichever value is closest to 1 is chosen as the optimal number of clusters. So we can see that k is equal to 4 has the silhouette score which is closest to 1. So k is equal to 4 is going to be used as the optimal number of clusters. So when applying for
Okay.
k-means, we'll use n clusters is equal to 4, and we're applying k-means. Here, clusters is just added as another label in the dataset. So when you're doing visualization, here we can see that 4 clusters are being made, but you can't interpret enough. And this green circles, yellow circles are in the middle of the purple circles, and you can't tell much about the uh, customers. So I did model tuning to look at the best parameters. So when applied, we get better clusters. So in this, for best score gives the highest silhouette score, and best parameters gives the parameters which are giving the highest silhouette score. Here initially it is taken as -1 because silhouette score ranges from -1 to 1. And we're checking for each of the PCA dimensions for each of the clusters. We're calculating the k-means and then getting the silhouette score for each of the clusters to get the best silhouette score. And then after comparing with each of the scores we're getting, best parameters are taken account. So in this
Okay.
output, we can see that these parameters are the best parameters, which is giving the highest silhouette score, and that is needed for clustering, for better clustering. And I've applied PCA using these exact parameters, and then I've applied k-means. Here, when I'm getting the visualization, this is way better than the visualization I got before model tuning, because here we can interpret them properly. There are 4 clusters, and we'll look into the interpretation. So
Okay.
cluster df clean cluster.value counts basically gives the number of points in each of the clusters. Here, for each of the clusters, I've taken the mean of each of the ages to get more interpretation. Here, for each gender, nationality, food preference, juice preference, as well as desert preference, we're taking the value count. So all of the number of data points. So for each of the clusters, we can see how many traditional food preferenced participants are there, as well as Western food. So based of all of these outputs, we can get these cluster profiles and labels. So cluster 0 has the largest size, which is, sorry, cluster 1 has the largest size, which is 128, followed by cluster 0, and then cluster 3, as well as cluster 2. And when it comes to age, cluster 0 has an average age of 27. The gender is balanced, that is, no gender is dominating that cluster. Food, the participants have mostly chosen traditional. Drinks, it's mostly fruit juice. Dessert, they have a very strong preference for dessert. And in the first cluster, the size is 128, age is around 36, it's female dominated. Traditional, the participants are mostly opting for traditional food compared to
Okay.
modern Western food. And then drinks, they're mostly choosing 100% of fruit juice, whereas dessert, it's mostly maybe or no. For cluster 2, the size is 17. Age, this is the youngest age compared to the rest of the clusters. And it's male dominated, it's highly diverse. That is, they're not only from India or one country, they're from everywhere. And food, they've chosen mostly traditional, but they are open than cluster 1. Here they are choosing entirely traditional. This is 100% fresh juice and mostly maybe dessert. Cluster 3 has the size 29, age is around 24 to 25, gender it's male dominated, food highest Western preference compared to the rest of the clusters. Cluster 3 has mostly Western preference. Food, drinks, highest carbonated drink usage, desserts, strongly, yes. So all of these clusters, through all of these clusters, the food industries can use this information to make targeted marketing, as well as personalized recommendations. These clusters help the food industries understand customer preferences, and they can use this to for their own purpose. That is all about this project. Thank you.
Okay, okay. So very well explained, Mansi. If there is anyone who having any doubt, then they can l- ask Mansi about that. So if there is anyone, just let me know. And Mansi, you has also, I guess, shared your project calibration report.
Yes, sir.
So yeah, that is also shared. Okay, okay. So great work, Mansi. Keep doing the
Thank you,
great
sir.
work. Okay. Now, Akash, you want to present?
Yes, sir. Yes, sir.
Okay, okay, Akash. Then just share your screen and let us know
Sir,
about
I
your
have to say,
project.
sir, I have to say something as I was not able to attend the week 2 and week 3 sessions as I was
Yes.
busy in my college curriculum. In the last week, I have internal, and before that last week, I have the fest in my college as I have already messaged you. So I have done my both the projects of week 2 and week 3, and week 4
Okay.
project I will show you in the Friday. Is that right,
Okay.
sir?
Yeah, yeah, no problem. You can present your previous week project also.
Okay, sir. I'm sharing.
Okay.
So my screen is visible,
Yes, your screen is visible.
and my voice is audible.
Yeah, it's clearly audible.
This is the week 2 project.
Okay.
Learning. I have choose the learning management platform on the full stack. I have a domain of full stack web development.
Okay.
Uh, I have worked on this project. A tech stack I have used front end I have used React.js, and for backend Node.js with Express.js, and database I have chosen MongoDB, and authentication is the JWT web token, as you all know about that JSON web token, which is
Oh,
generated to verify the user and
yeah.
when we log
Authentication
into
and
the website.
authorization. Yeah.
Yeah, yeah, sir.
Okay.
Yeah. So firstly, I would explain my project. So this is the project. This is the website web app I have made. Here we can log in to the valid credentials. There is an issue when I'm logging, but you can see as the home section and all that. So this is
Okay.
the courses, featured courses in my home section. These are the courses. You can enroll in any one of the courses like UI UX design masterclass. Enroll now, and because this is not now it is showing invalid credentials. That's why I'm not able to
Okay.
go
So
in that
is the
site.
code running in your local host currently?
Sir, this is the local host, as I have not deployed the project yet.
Okay, okay. And this is week two project, right?
Yeah, sir, this is the week 2 project.
Okay, okay, then no problem because up to then we have not covered the backend part. So you can just explain about the front end part using React. Okay, so don't worry about it if it is not working right now.
Sir, I have. Okay. So now I will explain my code part of the week 2 project.
Okay,
Uh, as you can see, a client and a server folder is there. Client is the front end, and server is the backend part of my code. For front end, this is the asset part, which is the static, as you know, image and all that part.
okay,
This is the components part. These are the usable UI components. Navbar JSX, which is the navbar handles navigation across. Sir, actually, I have a call. Can I pick that for one
okay,
minute?
yeah. Okay, okay, no problem. Take your
It's an
time.
urgent.
Okay, take your time.
Sorry for interrupting. I am back.
No. Okay, no problem. You can start from
So
where you
this
have
is the
left.
this is the nav bar. Handles navigation across the application, and this is the footer part, which is the last I have seen. You have seen in the website. Displays
Okay.
footer information like home section and all that things contains the footer part. And third thing is course card JSX, which is the card you are showing in my website as you have seen. These cards, DevOps Cloud and Python for data science, all that. These are the user card used to display individual courses details. And next I have the website pages, home page, dashboard, login and sign up, all that things cover up the pages. And after that, server kind. This is the backend part of server.
Okay.
This is the backend logic. So package.json file uh, contains dependencies and scripts for backend. And second thing is setup.sql. Sir, this file contain SQL queries, but I have not used, as I have said that I have used the MongoDB database. I have just used this for trial basis.
Okay, okay, no problem.
So this is not the actual env.env file, as we all know that this is the MongoDB URI, which connects the database to the project.
Yes.
and and which will and which remains. So this is the dummy data I have used for the cards, which is showing in the feed. This
Okay.
is the dummy data.
Here you are using bcrypt module also, so you know about that.
So which one?
The file you have opened just now, seeddummy.js. So here you are using a file bcrypt, like const bcrypt equal to require bcrypts where you are importing it. Yeah.
So
So
bcrypts are so for the bcrypt is used for the login credentials, and which converts the data into which secures the data,
yes, yes, yes.
encryption.
Basically,
Yeah,
yeah. If
yeah,
we are
sir.
taking the
That's
password from a user, then in our
yeah,
database,
yeah,
we
yeah,
want that will become in
yeah,
secure format. Yeah, so good.
yeah, sir. So that's it for the project two, and now I will explain my project third week of
Oh,
project.
okay, okay. Good.
Sir, okay. So this is the project for week third. I have made public SIEM registration system
Okay.
as a full stack development project. So wait for a while.
Yeah, no problem. Take your time.
So now I'm sir. Firstly, I will show you the I'm log outing, and now I'm login. So this is the login dashboard. When
Okay.
I'm login, so this will show because I have already signed in. So this is showing welcome back Akash Joshi. But first, when you will first log into that, this will not show. So this is the
o-
citizen dashboard. As I have designed two dashboards, but admin dashboard is not still working. This is the citizen dashboard where the schemes, government schemes, and all the things will seen here. So these are the schemes which is so these all are the DB data as I have used for that.
Okay.
So
Okay.
one for testing, I have applied for national scholarship scheme, but I'm working. I'm showing you choose file. Sir, choose file option means your documents section. मैं अभी कोई सा भी कर दे रहा हूँ document upload. When I'm
Mhm.
submitting, so this is the part which are showing my applications. As if I want to see my documents, I can see. So this is the random I have uploaded.
Okay.
Yeah, and this will I will make sure this will not shown in the website. So this is
Okay.
the profile section. This is the profile section. As you can see, role is citizen is visible here. As I have made for admin also, but still, but now it's not working, and I have not worked many more. So this is the dashboard. Open seams are you can see there are seven, and my applications only are two, and approved zero because of the approbation or all that things.
Admin
This
part
is the
is
footer
not
section.
working.
This is the seam section, and this is the home section.
Okay. Okay. Okay.
So this is the thing. Now let's move to the coding part.
Okay.
So in the tech stack, I have used for backend Node.js and Express.js, database MongoDB Atlas, and for frontend, I have used EJS and Bootstrap, and authentication, it will also the same JWT, and PDF generation, I
Okay.
have used PDF Kit. Sir, my project contains MVC architecture, as you know, model view controller, which separates logic for better scalability and maintenance.
Yes.
So let's move to let's move to my folder architecture. This is the
Okay.
SRC, which handles MongoDB connection. SRC config. This is the DB, MongoDB connection, and
Okay.
in controllers. So this is the application controller handles application. The part I have I have shown you the application part, and second one is auth controller. This will handles the login and registration part of my website, and this is the page controller. So this will render EJS pages. So the front end for the front end part, and this is the profile controller. As I have shown you the profile part. So this will handle the user profile logic. And second one is model. In model, MongoDB schema and all that things will define here. MongoDB schema or Mongoose and all that things, and all that things for that. And next for roots. So roots this for the API roots, showing the API roots. So this is for the application. This is for the authorization, and this is for the pages. All the API will which will calling to the backend from this part. These all are the API part which will authorize the clients and clients request. So next thing is I have missed middleware. Middleware part, as you know, this is the middleware authentication, sir, which is generate the JWT tokens and all that things, and is uh, it will also check the role based access, like as I have already told you, admin or citizen, and this is the service part, which is the this is the main part, which is the business logic part. As I have already told you, I have separated in the MVC architecture model view controller. So these all above the controller, and this is the main business logic part.
Okay.
So this make code usable and clean. So this is the
Okay.
application services counter document approved, or all that thing will shown there, and this is the scheme services.js and all the part.
Okay.
So next part is utils. So utils, it we can say it's a helper functions or common usable logics. Nothing more. This is
Okay.
the cache
So
async, and this is the page. So I have used pagination technique also in my front end or back end part. So this is for that.
Okay.
Yeah, that's all. And seed part, as I have already told you about, this is the dummy part and dummy data and all that things.
Okay. Okay.
So this
So,
is the and Ian.
yeah.
Yeah,
uh,
yes, sir, please.
I was saying, Akash, that see, up to week 3, like we have covered about React and the basics of Node.js, right? So whenever you are
Yeah,
trying to show your respective week project, then just make sure that the tech stack we have covered up to that in that particular week, you have to show the project related to that, okay? Because see, right now your admin panel is also not working, but that integration with the backend and database we have covered in the upcoming weeks. So don't present
yes,
the
sir.
project which is incomplete. Okay. So it will be good
Okay.
if you create that stack which we have already covered up to that week. Then it makes
So
more
actually,
sense. And
so
yeah.
so actually, week two project was working when I have checked in 5:30, but I think there is a issue, and I will check that
Okay. Okay.
project also.
No. Okay, no problem in that. But as I am also talking for week 2 also, because
Yeah,
there
yeah,
we
yes, sir.
have just covered React. So it is up to the front end
Yes, sir.
only. So that's why I said that you can fix it later on, because
Okay.
backend we have covered after week 3. So from there you have now next
Yeah, yeah,
project
yeah.
when you will get for the week 4, which you are going to present on Friday. Just make sure that
Yeah.
there all the things are working properly, because then I will check all these things which is there in the project. Okay.
Okay. Okay, sir.
Yeah.
So one thing I want to ask, sir, how can I submit these projects?
Okay, so like first of all, we have already mentioned that hr@gncipl.com is the mail. Okay, and you have to
Okay.
keep all these projects in your GitHub repository. So we
Okay.
will also, yeah, we will let you know that when you have to share that GitHub repository links, and also you have to share a project calibration report. I think that you were busy in your exam, so you have not shared it to me yet. So you have to also share that just in the group in which you are added. Check the
Yes,
files
sir.
like project calibration report. You will come to know that what you have to. Yeah, this one.
Okay, okay,
Okay,
sir.
so
Okay.
if you have already filled it, you can share that to me also. Okay.
Yes, sir. Sir, I have not filled yet, but I will fill and I will submit.
Yeah, for week 2, week 3, and for week 4 also you have to share it.
Okay, sir. Okay.
Okay, okay,
Okay, sir. Thank you. Thank you,
okay,
sir.
okay. Good, Akash. Now, are Pranav, are you there?
Sir,
Okay, so Pranav, have you completed your project?
yes, sir, yes, sir.
Okay, then just share your screen and let us know what you have created.
The screen visible.
Yes, your screen is visible, Pranav.
So, good evening, everyone. My name is Panesh Thakur, and my domain is AIML. And my project is on vehicle features clustering. The main objective of this project is to group vehicles into categories like fuel efficiency and performance without using any label data. So we are trying to find natural grouping in dataset. So let's start. So first of all, I have imported all the libraries in the dataset, which are pandas, numpy, matplotlib, seaborn, and standard scalar, k-means, slaughter score, and pca. Next, I have loaded
Okay,
the dataset. After loading the dataset, I have printed the first 5 rows of the dataset. After printing, we will be checking how many rows and columns in the dataset. As we can see, there are 398 rows and 9 columns. Then there's a
okay,
data information. It tells about all the outer columns, dataset columns, its type, and whether it's null or non-null count. Next, we have the statistical summary. So this table shows the summary about the dataset. As we can see that the average MPG is around 23, indicating a moderate fuel efficiency. Horsepower. Then we have the horsepower, which have so much variations, showing which shows the different levels of performance in the car. And also we have the weight, different types of weight, which tell there are also heavy lifted cars and also lightweight and heavy lifted weight cars, vehicles.
Okay. Okay.
Next, we'll be seeing any duplicate values. So we can see there are any no duplicate rows and column as well. Next is we will see any missing values in the data set. So we can see horsepower has 6 missing values. So in the data wrangling part, we will be handling it. So horsepower data set is very useful for us. So we will be converting into median. So we can also the median comes out to be 93.5,
Okay.
and after that we can see there are no missing values left. Also, I have taken median because median is better than mean also, and it give better imputation. Next, I have the EDF day which I have the 8 graphs. First is the MPG distribution. So basically, MPG is like the fuel efficiency. It tells the how much the car is taking fuel. So we can
Okay.
see that an average the car is taking out 13 to 14 mpg liters. Next, we have the horsepower versus mpg. So we can see that if we increase the horsepower in the vehicle, the mpg is also decreasing. Means if we increase the horsepower, the mpg is also decreasing. It also shows a very negative trend. Next is the
Okay.
weight versus the mpg. So this tells about the weight. It also tells about the weight versus MPG. If we if the car has more weight, it MPG moves will be lower because heavier vehicles need more power. So their fuel efficiency is also affected by this. Next,
Okay.
we have the correlation heat map. So these suggest the positive correlation. After this, we are having the horsepower versus weight. So uh, uh, we can see there is a positive trend because heavier weight require very high horsepower. So we can see the horsepower is also increasing due to the weight. Next, we have the cylinders versus the MPG. So we can see that as we increase the cylinders, our MPG also decreases. But if we put 4 cylinders in the vehicle, the average MPG is stable, is good. So
Okay.
4 is minimum we can take. Next, we have the acceleration versus the horsepower. Uh, as we can see, if horsepower is increasing, acceleration should also be increased, but in this trend, it is decreasing due to some of the heavy vehicles which have the
Okay.
heavier weight. Next, we have the origin and the MPG box plot. So this tells the countries which are having good MPG. So we can see Japan and Europe have much better MPG cars and compared to USA. After ED, I have used a standard scaler for so that uh, it helps in the clustering process, and also there should be no dominance in the features. Next, I have used the elbow method. Uh, so, elbow method. So elbow method is suggesting that there should be at most 2 or 3 clusters. So for analyzing it, we can slaughter score. So slaughter score is indicating that 2 clusters is required for the
Okay.
cluster, but we can also take 3 clusters. I will be explaining later on. So after that, I have the K-means clustering. So K-means is used to group vehicles into different clusters based on the features. Next, I have performed the PCA, principal compound analysis. As we can see that the clusters are separable, but they are also overlapping with each other. So we can see that. So next is the cluster insight. From this, we get from cluster zero. This shows that have higher horsepower. So this cluster shows the high performance vehicles, and this cluster is showing fuel efficient vehicles. So
Okay.
if we change our cluster, if we change cluster to 3, and now if we see that the if we use the 2 cluster, the score was 0.48. If we use 3, it was coming 0.35. So, and also if we change the means, so we can see that they are also making a cluster, but this cluster is making very overlapping
Okay.
with each other. So
Yes.
3 clusters was giving a better understanding, but two was very getting two was getting better results. So in,
Okay.
also in this insights we can see, also we can see that this cluster is showing high MPG, which means lower performance. This cluster is showing medium balanced vehicles, and this cluster is showing high performance.
Okay.
So K is equals to 3, giving, so 3 cluster were giving more detail, but 2 gives a better separation. So I have used the 2 clusters. Next, I have performed the model tuning. We used tell 2 to 9. So 2 was giving the best score out of it. So after that, I have used on the plot also. So the final conclusion is that the vehicles can be broadly categorized into 2 segments, which is the fuel efficient and the high performance vehicles. So this was my overall product. Thank
Okay.
you.
Okay. Good work, Pranav. And also, I think you have shared the project calibration report. Let me just check for a second. Just a
Yes,
second.
yes, sir, yes, I have shared it.
Okay. Okay. Yes, you have shared it. And if anyone is having any doubt regarding Pranav's project, then they are open to ask any question or query related to that. And if there is any suggestion they want to give, then you are also welcome for that. So anyone who wants to say something?
I want to
Okay.
ask if to give something. Feedback.
Sorry, what, Pranav?
I want that you should give some feedback.
Okay, so basically, Pranav, the thing is that whenever you are presenting, so just make sure that sometimes you have to take the pause also. Okay, like you are able to explain charts more, but whenever there is a code written, basically try to move fast from there. So make sure that whatever the code is also written, you have to also explain that in order to that user can understand, okay, that on behalf of that you have created this. Okay, so this will be my suggestion to you, but I know that you already know the meaning of the code, but it's the thing that it will be very good if you try to make that clear to others also, that why you have used this segment of code. Okay.
So,
Okay.
thank you, sir.
But still good presentation. So great work, Pranav. Okay, so now the Pranav is done. Akash has also presented. Mansi has presented. Okay, Priyanshi, you want to present?
Yes, sir.
Okay, okay. So just share your screen. Let us know about your project first.
Is my screen visible?
It's loading for me. Just a second. Yes, now it is visible.
So my domain is AIML and this is my project IoT device grouping
Okay.
based on uses of devices. So I have taken data from Kaggle named home CSV. Uh, in this, there are too much features like for you can see here the home appliances and also the weather type of IoT devices like pressure, wind, speed kind of. So we will remove those columns. We will just work on our home appliances. So we selected these features And you can see here the time. In this, you can see our IoT device generally take logs for every second. So the data is very spread out. What will it give later? Very distributed and spread out. So making cluster of this kind of data set is very tough for k-means, but for higher um, like a hierarchical clustering works better. But in project we have k-means, so we used k-means.
Okay.
Here we remove if any missing values here, and drop any duplicate columns, means rows. And then we I added this code after I have analyzes my code, because there's too much outlier here, as I said, that this data set is very spread out and very noisy data set. IoT devices generally gives very noisy data set, and working on that is very difficult. So now I standardize our data. This what this does it make all the features mean to 0, and deviation to 1. So that our data set can be centered, which is good for clustering.
Okay.
Now we did EDA, and we can see here the mean becomes 0 for all. And now we shown this on our heat map, and we can see here also features are not correlating very much, because uh, very much disturbance and noisy data set it is. And I have taken a very uh, few rows, 35,000, because Google Colab crash out when I take too much. So it's like 35,000 seconds of data.
Yes.
Now I have done box plot, and here you can also see, after removing outliers and standardize, still there are outliers in furnace to dishwasher and other home appliances. And
Yes.
now we did PCA, principal component analysis. It just reduced to two-dimensional, best for showing it on a graph. And also this PCA data is useful if we want to just for learning purpose, if we want to just cluster, not actually deploying the model. And when I make my model k-means on this PCA data, it gives better score, which is
Okay.
silhouette score. It gives better score, but when I no, work on my normal scale data, it give lower. But as if we want to deploy our model, we will use this scale data, not PCA data. Uh, it will give best for only learning and for clustering here, but not work on our real world data, because it just make new features like PCA1, PCA2, and which has no actual meaning, like is PCA1 is temperature, PCA1 is voltage. So we will not use it. Now we do clustering, and as it is unsupervised learning, so we don't know the actual value of k, but we will use how many cluster we are actually making. So the main point for unsupervised learning is to find the value of k. So we will
Oh,
apply so many analyzes here and graphs to check and find the average out what we can use. So here I run for a 1 to 10 range. And if we see here, after a very um, steep line, there's a little horizontal kind of, it's not actually horizontal, but it's very you can see this steep is degrading here for
yes.
from 4 to 5. So we can take 4 or 5, but it's still not sure. We cannot alone rely on this elbow method. We will use our silhouette score. And again we run it for 2 to 6 range, and we can see for 5 it is giving 0.33 score, which is good, and for 4 it is giving 3.31. So we can take 5, but we will again do one after we tune our model, we will actually confirm what value for k we gonna take. So here I also did this on our PCA data.
Okay.
Like I told you that I have worked on this before. Then I worked on scaled, and here you can see it is giving higher score than our scale data. It is giving 0.43. Um, for IoT devices, these scores are good, but for other, if we work on our other data set like songs and all, so then this score is not good. But IoT devices have very much noise and disturbance in data set, so these are good for
Okay.
k means. And now here here we take 3, but we will change it after. We just did this to uh, check for our model tuning. And now we use hierarchical clustering also for analyzing how is it working on hierarchical clustering dendrograms. We will show that in our graph. And we use TSNE analysis. It's just like PCA analysis, but it is non-linear. The only difference
Okay.
in this and PCA is it is non-linear and the PCA is linear. Now
Okay.
we did model tuning, and we take k-means and cluster to 2, 3, 4, 5, and max iteration is 100, 200, and 300, and init k-means plus plus and random. And now what this grid is search CV, our model tuning method do is this work on this all combination, make all possible combination, and give its best combination after all the processes it do. And it gives us the um, best combination which works good.
Okay.
Like init random, it gives init as random, and k means max iter 100, and k means n cluster 5. Now it's clarify us that we need to make 5 clusters. Now we'll make 5 cluster, and we did PCA component tuning too. And here you can also see that 4 to 5 it is deviating. And now we have confirmed that we need to take 5 cluster. Now we will pass that hypertuned parameter to our k-means and make our k-mean model, and fit predict our k-means, and finally make final cluster column in our data set.
Okay.
And now we will visualize it. We make a PCA cluster plot. Here you can see, after doing so much outlier reduction and all those things, and still there are too much outliers here, and they are again they're still overlapping each other, but k-means try to make clusters. And
Okay.
we shown our centroid where the centroids are. Here you can see the centroids for each 5 clusters. Now we make our dendrograms for all 5. This graph is too meshy because here what it takes in x-axis is all 35,000 rows, and make a tree-like structure.
Okay.
It also gives 5, shows 5 how it is made. And now we did our TSNE plot, and here you can see the yellow and it making cluster here and here too. So as I told you that it's there's too much outliers and very noisy data. We
Yes.
have cleaned it, and it is still giving that. And now finally we did our slotty score, and it's giving 0.35. And before I have tried so many techniques. We take I have taken k is equal to 3, means 3 cluster I have
Yes.
tried, but for 5 cluster it is giving higher value than others. And when we did this on PCA data, our principal component analyzer data, it gives around 0.5. So
Okay.
but we will not work on that. So that's my
Okay.
project.
Okay. Okay. So good work, Priyanshi. Good explanation. Keep doing like this. And you have also shared the report with me. I have checked that. So, okay.
Yes, sir.
So now, Pranav, Lalit, are you there? Yes. So, Lalit, have you completed your project?
Yes, sir.
Okay. Okay. So, just share your screen and let us know what you have created.
The- my screen is visible.
Yes. Now it is visible.
So, sir, myself, Lalit Bharadwaj from domain AIML, and
Okay.
I have worked on the project named Stock Movement Cluster.
Okay.
So, sir, the main objective of the project is to tracking of the stock price movement of the tech giants manually, and sorry, not manually, but using the help of AI functions. So, in today's world, it is very difficult for tracking the price movement manually. But for there are uh, there are very hundreds of companies across different sectors, and so tracking them them at a same time got very difficult.
Yes.
So in this project, we used some AI model functions which automatically find the hidden relationships in the stock market without any human interference.
Okay.
So, when a retail stock might start behaving like a tech stock. When a retail stock behaves starting like a tech stock, because the company who from by the retailer just launched their app, so it might get the fluctuations in their stock prices. So, but at that point, humans might miss the uh, fluctuation by not getting the complete information about that stock. So
Okay.
here our project comes in the play, and it uses some mathematical functions to track it.
Okay.
And if you are an investor and you don't want all your money in a stock that which could crash on the same day, but this model would help you to see which stock are basically twins, so you can spread your money safely across different groups. So starting from here, importing
Okay.
libraries. Here I uses these functions like yfinance for importing the libraries and pandas, and also we have I have done this for building a clustering algorithm from scratch.
Okay.
So uh, and these libraries will help them with some ready-made clusters and libraries also, which helps us to perform the mathematical functions for analyzing those stocks movement. And from for here, we downloaded and fetched the data from those libraries like Yahoo Finance, and it what it does it grabs one full year of daily final prices.
Okay.
That the close prices where at the price where the stock closed from trading it. for local investors like our normal persons. And I have chosen which Apple and Google, Microsoft, Amazon, Walmart, like these companies for as example. And so it generally it gives us a clean and universally accepted data set, which is very clean and easy to understand
Okay.
to invest in different stocks. So next comes to pre-processing, and what it does that the extracted data from libraries and downloaded fetch data, it simply makes that data usable for us. So it generally converts the raw stock date prices data into daily percentage changes. Like example, any stock goes up for 2% or down anything. So it tracks that data and changes that raw percentage into user readable data. So and it also standard make the numbers very balanced and standardized. So like for example, for example, just a minute, let me get something. Okay, so like imagine comparing a stock that costs rupees 10 with one
Okay.
another stock that cost rupees 5,000.
Okay.
So if the 5K stock, 5,000 rupees stock moves by 10 rupees, moves up by 10 rupees, that's generally very minimum percentage for it.
Yes.
So if the stock rupees 10 stock moves by 10 and it got doubled itself. So it that raw price tricked the AI in
Okay.
getting confused. So by using daily percentage changes and scaling them, we level the playing field in a balanced seat. So the AI now can fairly compare that a giant company with a small company, and it compares it purely on the behavior basis. It does not compare that on the price basis. So by using that daily percentage changes up and down
Yes.
and scaling them, uh, we level it on a balanced chart form. So the AI now start comparing on their level.
Okay.
Then comes to the processing dimensionality reduction. So here we uses the PCA, and it it consists like 250 to here. For an example, like we take 300 days of trading data, then it converts that into 300 columns, and that 300 columns converted into two super summary columns, which contains like and two columns, all the 300-day data. So, and like we cannot see or calculate that 300 column data into one view, but
Okay.
uh, using the computer uh, devices, we can visualize that.
Yes.
So, and here PCA, most PCA helps in the most important trend in that whole year of data and packs that into just an uh, graph form X and Y axis. It allows us to actually draw a simple 2D map of the stock that which anyone can understand. So
Okay.
here comes the elbow method, and it what it does its function, it tests out and it creates 1 to 10 different groups and records it how complicated the group and get each time
Okay.
like when creating every group, and it makes different groups on their complexity levels. So, and here it doesn't know that if we tell it to make 100 groups out of 100 companies, it will just put each company in its own group, and which doesn't help us anymore. So the that this elbow chart, it gives us the mathematical proof of the perfect balance,
Okay.
and it shows us exactly where adding more groups stop being useful, and it removes the human interference in it,
Okay.
like guessing thing, and here the comes clustering function. So these are both the same parts. I have written them separately.
Okay.
And here the this it uses an optimal number, uh, optimal number like this 10 or 7, and to lock it in the final groups, and
Okay.
and then uh, assign a separate cluster, numbering to numbered them by their companies, like every companies, and so to finalize that this pattern recognition of number grouping them and numbering them, that
Okay.
here comes the k means, and it
Okay.
calculates the center of the each trend, and like it pulls similar companies and uh, grouped them into their center, towards that center, where every company comes to similarities, and the mm, now no yeah, visualization insight function. So this code for the generation of the visuals and code, and
Okay.
maintaining them according
Okay.
to. So, sir, um, the first chart shows the elbow method. Here, the graph shows like forming an human elbow,
Yes.
and it. Sir, here the x-axis shows the number of clusters, and y-axis shows the errors in that cluster. So when moving from one to second cluster, another cluster, the error drops immediately. But from moving from second cluster to third cluster, it again drops. But around three to four cluster, the line got starting flattened. From
Yes.
this angle, it gets flattening. So that band in the hair, the band in the line, this band is called the elbow. So that's why its method is called elbow method. And uh, this and the this tells us that for 4 point is the optimal number of the groups, or all the groups of companies and their stocks.
Okay.
It is the optimal number, and then it goes again down to up to 8. Then here comes to the second chart for the scattering of clusters. So here the this visual it proves that our AI functions that we use is the on the above
Mhm.
uh, uh, worked very well, and gives us the favorable output.
Okay.
So and in this chart, this the x-axis and the y-axis. These are both the summary columns, and we created them using the we created them using the PSA. Oh, sorry, PCA. And here every dot on this chart shows a company, and these are colorful because the AI function that we uses separated them using their similarities.
Okay.
Like these four have some similar features, and these four,
Yes.
these two, and these three.
These four. Yeah.
And if you here look closely at the plot, you will see that companies from similar industries, like these four comes from the similar tech backgrounds. Why AI the separated them closely very because they have some similar tech backgrounds, or like they comes from the similar product or tech industry uh, that thing is common in all them. So that's why they grouped them here on these four here.
Okay.
So, but in the above code, I have not told the in the coding to to may choose that color, same color, or clump them together very closely.
Okay.
So it simply figured out that their stock charts looked identical. similar, like they all have on the single time. Uh, the prices are almost similar or up to on the provided range, in the
Okay.
provided range.
Mm.
So uh, and these are that tracked range was about from over the last years, last 1 year. So that's why they grouped them. And
Okay.
uh, now we have companies and similar companies in there and here, which and it is also helpful in the building of automated trading bots, which I some ta- some bots like sir, like have you heard of Binance application?
Uh, which
Sir,
one?
the Binance application, which is
Yes.
a crypto-based application.
Yes,
It
yes.
also have a function which uses the trading bots, and it also on the based on this project, it uses some functions of this project,
Okay.
or not. It uses I uses that some function in my project, so it is helpful in them, and other many apps uses these functions for making their trading bots.
Okay.
And uh, so finally the cluster zero here, the cluster zero comes to C cost and APL apple. Here it shows this, and the cluster one, which is blue colored, it shows the BAC, GS, JPA, Morgan, and TGT. And cluster 2 shows JNG stock, PFP stock, and this cluster 3 shows Amazon, Google, Meta, and Microsoft stock.
Okay.
So that's all, sir. Thank you, sir.
Okay. Okay. So good work, Lalit. And one more thing that you have to also share the project calibration report. Okay. So also share that and good
So
work.
I have made, but a few things I need to change. So
Okay.
that's why I will send you till night.
Okay. 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 No problem. Okay. Good work.
Thank you, sir.
Okay. So now, Divya and Yatham, you both are left. So have you also completed your project?
Yes, sir.
Okay. Okay. So Divya,
Yep.
just share your screen. And then at last I will take for you, Yatham. Okay.
Sir, is my screen visible?
Yes, it is visible, Divya.
So, sir, this is my project, customer segmentation in e-commerce using RFM analysis
Okay.
and K-means clustering.
Okay.
So, the main goal of the project is to segment the customers into different groups based on their purchasing behavior. So, in e-commerce, we treat all customers in a similar way, but it differs based on their purchases and activities. So for that, I have imported to analyze their behavior. I have imported libraries like pandas for importing and loading the data set, numpy for numerical calculations, matplotlib and seaborn for graphs, and
sklearn I have used for all pre-processing works, and different lines mean different meanings. And then I have connected my Google Drive to the Google Colab, and loaded the data set, and displayed the column names. And using a head function, I have displayed the first 5 rows of the data set, so that I can know how the data set looks. And then I have used the shape function to display number of rows and columns. Here we can see like we have almost 5,41,000 transactions, that is rows, and 8 columns. And to
Okay.
display the dataset information, I have used .info function, and displayed the information like column names, their data type, non-null, count, and etc. And for understanding the variables in detail, I have displayed the column names and data type, as here you can see. And I have calculated all count, mean, standard deviation, and numerical calculation using describe function. And variable description, like I have described every column name and their meaning. Here, like invoice number is a unique number assigned to each transaction. Stock code is like a unique identifier for each product. Description, name or description of the product. Quantity is like the number of units of a product in a single transaction. Invoice date is when the transaction has happened, and unit price is like price per unit of product. Customer ID is like unique identifier for each customer, and country is like at which place the transaction took place. Then in the
Okay.
data processing part, I have handled the missing values. As we have almost 5 lakh rows, so there is no need of particular values for each row. So I have handled the missing values. Then I have handled the positive values of quantity and unit price, as here we can see. And after handling, I have checked again for missing values. There are no missing values in any column. And for handling duplicates, I have used the same. I have dropped the duplicate rows. Then in feature engineering process, I have calculated the total price with the formula like quantity into unit price, and invoice date I have converted to date time to get the exact time of the transaction. Then I have calculated the latest date of the whole data set, and with that I have calculated recency for each customer, so that we can understand that how recently a customer has purchased any item. And frequency is like how many times did the customer go for a shopping frequently, like that. And monetary is like the total amount he will be spending on the shopping. Like that, I have created 3 columns like recency, frequency, and monetary. Then I have displayed this like this. Here you can see. Then for treating outliers, first I have checked for the outliers, and use the box plot. These dots represent the outliers. Then for handling that, I have used IQR method and replaced the outliers with the median. Then again, I have checked for the outliers. So the mostly
Okay.
outliers are replaced with median, and some outliers are there that we are the like the common values we can see. Then in feature scaling, I have scaled all the columns into similar range of values, so that no features become dominant. And scale the whole data into 3 columns like recency, frequency, and monetary, and converted into log, so that it reduces skewness. Then I have
Okay.
performed exploratory data analysis to understand the relationship between the variable. And I have did a correlation heat map, like dark red color is like there is a strong relationship between those variables, and blue is like there is a weak relationship between the variables, and these values also we can see here. Then I have applied a principal component analysis, that is I have reduced RFM into 2 main components, and I have analyzed the data. And here we can see like the first principal component almost analyzes 64% of the data, and second principal component analyzes 24% of the data. So total, the both components analyze almost 89% of the data, which is enough for visualization. Then I have used K-means clustering for grouping the customers into segments, for to know how many clusters we have to divide the customers. I have used elbow method and silhouette score. In elbow method, we check for the point where the curve bends in the form of elbow, and in the y-axis we can see the error, and x-axis we can see the number of clusters. So we check for a point where there is a bend like an elbow, and we can see that there is a bend like an elbow at 3 and 4. Then
Okay.
I have used the silhouette score method, and we'll here see for a point where there is a high value of silhouette score. We see that there is a high value of silhouette score at 2 and 3. 4 also we can consider, as there will be a good separation. Then I have applied k-means clustering with k equals to 4, considering the both elbow and silhouette score method. And like after applying the k-means clustering, when we use head function, we can see that we have got an extra column like cluster. And for each customer, we will be getting the cluster number. Then I have used the hierarchical clustering so that I can compare the results of k-means clustering with the hierarchical clustering. And
Okay.
then feature like recency, frequency, and monetary, so that I can understand how these clusters are interpreted. And here we can see like cluster 0 has a low recency, some high frequency, and a high monetary. Like based on this, we can say that cluster 0 has risk customers, as they will be buying recently, and they have frequency and monetary less than other groups. So like that we'll be interpreting. And to
Okay.
know the how many customers are there in each cluster, I have used another graph. As you can see here, we displayed the count for the every cluster, and uh, mentioned in the bar graph also. And
Okay.
then I have visualized the clusters with PCA, and so that it gives general view of all the clusters. Like here we can see there is a general view of the clusters. Then I have used TSNE visualization so that it gives the um, neighborhood of the clusters. Like PCA gives the general view, but TSNE gives the close view of the clusters, as we can see here. Then cluster interpretation, like cluster 2 are the best customers, as we have seen in the above graph. Based on that analysis, cluster 2 are best customers. They spend frequently, more money, and purchase recently. And cluster 0 are regular customers. These customers buy regularly and spend a moderate amount. And cluster 3 are risk customers. These customers spend, they haven't purchased recently. And cluster 1 are the low value customers. They buy often less and spend very little. So
Okay.
we can use different strategies for each cluster, so that we can attract them more to make purchases more attentive. And for that, for best customers, we can give loyalty programs like early access or premium accounts like that. And for regular customers, we can encourage them by giving discounts, offers, and like that. At low risk customers, we can give special coupons and send mails uh, on discounts like that. And low value customers will be doing increase their activity by marketing campaigns, offers, and awareness camp. So for model tuning, I have used the elbow method and silhouette score. Based on that method, I have used k equals to 3 or 4, which gives good results. And we selected k equals to 4 because it provides better and more detailed customer view. That's it.
Okay. 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 So good work, Divya. And today everyone has given a great presentation. So very well done, guys. And now we are going to connect on Friday and we'll take the remaining presentation of the students. So great work, all of you. keep doing like this. Now you have to complete your week 5 project also. So make sure that you are taking all the sessions on regular basis so that it will help you a lot while creating the project. And that's it for today's session. I hope that everyone has given the presentation. Only Yatham is left and he is going to give the presentation on Friday. So yes, we are good to just wrap this session. Thank you, everyone. Happy learning.
Thank you, sir.
Thank you.